Hello students, welcome to the channel. In today's video, we'll solve the science section of the July 2020 ACT Form C01. So let's begin. Passage 1. The termite Reticulidermis flavipes consumes wood and bark. A study examined whether the consumption of wood or bark mulch by R. flavipes varies with the type of mulch or the age of the mulch. Separate portions of each of 5 types of mulch were aged, allowed to decay for 1, 24, and 48 weeks. Then 2 grams of each type of 1-week-old mulch were put into a box. 2 grams of each type of 24-week-old mulch was put into a second box, and similarly for 48. Next, 1 gram of R. flavipes was added to each box. After 15 days, the mass of mulch consumed in milligrams was determined for each type and age of mulch. Okay. Of the following combinations of type of mulch and mulch age, which combination resulted in the greatest mass of mulch consumed by R. flavipes? Greatest mass. So greatest mass of mulch is this one, which is cypress for 48-week-old mulch, right? Oh, only from these. Okay, sorry. So oak 24, pine bark 24. Okay, only from these, not overall. So that would be oak bark, and what else? Sorry, oak, pine bark. Okay. So oak and pine bark. So I'm looking at 24 and 48. So this is oak and this is pine bark, and this is oak, and this, yeah, so it'll be oak for 24. Yeah, A. Which of the following statements about the effect of mulch age on the consumption of mulch by R. flavipes is consistent with the figure? As mulch age increased from 1 week through 48 weeks, the mass of mulch consumed it from 1 to 48, right? It always increased, right? No, but in the case of oak, it increased and it then decreased. In the case of cypress, it increased. Cedar, it increased. Yeah. For 2, which ones are we checking? Yeah, initially increased for all types of mulch, but then decreased for some of the 5 types. Yeah, J. Because it did not consistently increase for all of them. Based on the passage, would R. flavipes be classified as an autotroph or a detritivore, and why? Okay, so it obviously is not an autotroph because it consumes, it doesn't produce its own energy, right? It needs to consume mulch. So it would be a detritivore because it obtains energy by consuming detritus, decaying organic material. Based on the passage, is the primary food source of R. flavipes more likely cellulose or cholesterol? Okay. It was mulch, right? Right. So cell walls, right? So it's basically consuming plant, and the plant walls consist primarily of cellulose. So it'll be G. Which of the following statements comparing the consumption by R. flavipes of 1-week-old oak mulch, 24-week oak mulch, right? 1, 24, and 48. So I'm looking at oak. So this is oak, right? So it went like this, right? It increased and then decreased. More, less 1-week-old mulch was consumed in this, and more, yeah, so it's D. What mass in grams of the 48-week was consumed by our oak bark? oak bark, which is this one, right? 140 milligrams. 140 milligrams is 0.14 grams, right? So, yeah, because milli is 10 to the power negative 3, right? So it's 0.14. Okay, samples of species C bacteria must often be transported from the areas in which they are collected. During transport, the samples are typically packed in ice to keep them alive. However, ice is not always available where the samples are collected. Scientists studied how lyophilization, a freeze drying process that doesn't require ice, followed by incubation, affected the survival of two strains, strain E and strain V2 of species C bacteria. The scientists placed a 100 microliter sample of a nutrient medium containing 4 into 10 to the power 6 strain E elementary bodies into each of 8 sterile test tubes. An elementary body is the infective form of species C. The sample in each of the tubes was then lyophilized and each tube was sealed. 2 of the tubes were incubated at 4 degrees, 2 at 20 and 2 at 30 and 2 more at 37. 1 week after the start of incubation, the percent of elementary bodies that survive was determined for the samples in one of the 2 tubes at each temperature. Then 1 month after the start, the percent survived was determined for the sample for the remaining tube. Okay. The scientists repeated this experiment with strain V2. Okay. Which of the following statement describes the difference between experiment 1 and experiment 2? Okay. So, yeah, right. A different incubation temperature, a different strain. So it was a different strain, right? B. Suppose that in experiment 2, the scientists had determined the percent survival for a sample incubated at 25 degrees centigrade for 1 week. The percentage survival of strain V2, 25 degrees centigrade for 1 week. So that's between 20 and 30. So it would be between 2 and 29%. Between 2 and 29%. At which 2 temperatures was the percent survival of strain V2 elementary bodies less for the longer incubation time than for the shorter? Percent survival less. Okay. So, yeah, it is at, wait, what am I doing? Less, right? So it is these two, 4 and 20. Or 4 and 20. Which of the following questions was not addressed by the experiment? Does incubation time affect the person's survival? That was addressed. Temperature, yes. Does the number of strain present in a sample before lyophilization affect the person's survival? We did do that, right? We did. Okay, so it was not all. Number of strains was the same. So this was not tested. Do strain have a greater percent? Yeah, so J was tested. So H was not tested. 1 week after the start of incubation, which of the 4 samples of strain V2 elementary bodies would have been least likely to infect another organism that came into contact with the sample? 1 week after this, which of the 4 samples? 1 week. Okay. So this is we are looking at the infective form of the species, or the lowest. Lowest is least likely is the 37 degrees centigrade, right? 37. Suppose that a scientist wants to transport a lyophilized sample of strain E elementary bodies based on the results of experiment 1. Which of the following combinations of temperatures and transportation would most likely ensure the greatest percentage survival? Greatest percentage survival is here, right? So 1 week and 20 degrees centigrade for strain E. 1 week and 20 degrees centigrade. Consider the rating system in the table below for the person's survival of elementary bodies after lyophilization. Based on this table, what is the total number of tubes in experiment 1 that contain samples having a poor percent survival? Poor, less than 30%. Total number of tubes in experiment 1. Okay. Less than 30%, right? So that would be 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 4 tubes. Okay. Passage 3. When an object is submerged in a fluid, the object displaces a volume of fluid equal to the object's submerged volume. The fluid exerts an upward buoyant force on the object that is equal in magnitude to the weight of the displaced fluid. The object floats if the buoyant force equals the object's weight. A group of students conducted 2 studies on buoyant forces using 3 fluids, water, fluid A and fluid B, having densities of 1, 1.25 and 1.5 respectively. The students placed a 10 centimeter long cylinder in a container of water and measured the length of the portion of the cylinder that was submerged. They then repeated this with fluid A and fluid B. Okay. The students placed a stone, either stone X, Y, or Z, in a net that was tied to a spring balance. They recorded the force measured by the balance as the stone's weight. They then submerged the stone in water and again recorded the force measured by the balance. The students calculated the buoyant force on the stone in water as the weight minus the force that was measured when the stone was submerged. They repeated this procedure to test all 3 stones in all 3 fluids, and table 1 lists the stone's volume and the weight as well as the buoyant force. Okay. Based on the results of study 2, as the density of the fluid in which stone X was submerged increased, the buoyant force on stone X. So density increases in this direction, right? So the buoyant force also increased on stone X. It increased only, right? Based on the results of study 2 for stone Y, what was the difference between the buoyant force in fluid A and the buoyant force in fluid B? 1.18 and 1.41. So 11 minus 8, 3, 0.23, right? 0.23 newtons. Suppose the students decide to study whether a cylinder's volume determines the submerged length of the cylinder in a given fluid. Which of the following procedural changes should the students make to study 1? The students should test cylinder's volume determines the, they should, a single cylinder with multiple fluids, the fluids should each have the same density as the cylinder. Multiple cylinders with a single fluid. The cylinders should have different volumes, but the same density. So if you want to test whether the cylinder's volume determines the submerged length of the cylinder, then you should definitely take different cylinders with different volumes, right? So it will be H. Yeah, but they should obviously have the same density, because only then will you be able to make a comparison between volume and the submerged length. In study 1, did the cylinder displace a greater volume of water or a greater volume of fluid A? It displaced a greater volume of water, right? Because it was more submerged in water. Water, because the cylinder submerged length was greater in water than in fluid A. Suppose that in study 1, the students had placed the cylinder in a container of fluid having a density of 1.6. The submerged length of the cylinder would most likely have been 1.6, right? So 1.6 would have been the submerged length would have been less than 4.9. Yeah, less than 4.9. Suppose that in study 2, the students had tested a stone having the same weight as stone Z, but a larger volume than stone Z. Which of the following statements about the buoyant force would be correct? Larger volume. So this is larger volume. So this Z, let's say it's 100. Z1, it's a new stone with the same weight but a larger volume. Submerged stone. Okay, so see, if the same weight but larger volume, so what would happen? Because see, as the volume is increasing, because see, weight is not affecting the values, right? It's only the volume. Because as the volume increases, the buoyant force also increases, right? So it would have, the buoyant force would have been greater than 0.94. Yeah, fluid B greater than 1.41. So it's this. Assume that Atlantic Ocean water has a density of 1 gram per centimeter cube and the Pacific Ocean water has a density of this. In which ocean would a given iceberg more likely have the greater submerged volume? So as the density increases, the submerged volume decreases. So it would obviously be, the greater submerged volume would be in Atlantic because the volume increases as fluid density decreases. No, submerged volume decreases as fluid density increases. Submerged as fluid density. Wait, so it's going to be F, because if the submerged volume is increasing, the fluid, yeah, so F is correct. Okay, chemical reactions that release heat are exothermic reactions. Amount of heat released depends on the number of moles of reactants consumed in the reaction. A mole of any substance is 6 into 10 to the power 23 molecules or formula units of the substance. When sodium hypochlorite, NaClO, and sodium iodide, NaI, are dissolved in acidic water, an exothermic reaction occurs. It produces heat. Students did an experiment to study this reaction. In each of 8 trials, the students performed steps 1 through 5. A known volume of 0.2 moles per liter aqueous NaClO solution was poured into a foam coffee cup. A lid was placed on the cup. Thermometer was placed into the solution through a hole in the lid. The solution's initial temperature of 22 degrees centigrade was recorded. The lid was lifted and a known volume of 0.2 moles per liter aqueous sodium iodide solution also at this temperature was poured into the cup. The lid was put back and the solution was swirled. The solution's final maximum temperature was measured. The change in temperature was calculated. The students plotted delta T versus the volume of NaClO for each trial. Then they identify the trial for which delta T had its greatest value. The ratio of the volume of the NaClO solution to the volume of this for this trial is known as the mole ratio for this reaction. Okay. So greatest delta T, right? Okay. If a trial had been performed with 60 ml of NaClO solution and 40 ml of this, what would the final temperature have been, right? T final, yeah. So we are doing 60 and 40. So we are between these two, right? So it would be between 29 and 31. Between 29 and 31. Before the experiments, a student predicted that delta T for trial 2 would be greater than delta T for trial 6. Do the results support? Delta T for trial 2 would be greater than delta T for, no, that's not true. No, delta T for trial 2 was less than delta T. How much less? It was 5.1. Yeah, so it's F. In each trial, the total volume of solution poured into the cup was volume, it was 100, right? Total solution poured in the cup was 100. Consider the trial for which the volume of NaClO was 4 times as great as the volume of this. For this trial, T final was 4 times. So that would be 80 and 20. So that's 30.6. 30.6. Suppose a trial had been performed with 20 ml of NaClO solution and 80 ml of this. Based on this, delta T for this trial would most likely have been 20 and 80. So it would have been close to 3, right? Little less than 3.5. So it will be 3. Yeah. Which of the following statements best explain why delta T was 0 for trial 8? The volume of solution added was 0 ml for one of the trial 8, for one of the products, right? So no reaction had occurred. One of the, wait, what is it, the product or the reactant? It's a reactant, right? Yeah, it was the reactant which was poured. So it was 0 for iodide. So one of the reactants. Yeah, so J. Suppose that the reaction studied had been endothermic. As the endothermic reaction progressed, would the solution temperature more likely have decreased or increased? So if it's endothermic, it would decrease because the reaction would have absorbed heat. Yeah. Okay, passage 5. When rocks are melted at very high temperatures beneath Earth's surface, magma, molten rock, is formed. The gases CO2 and water can dissolve in magma. Figure 1 shows for 4 different magmas, leucitite, basinite, rhyolite, and theolitic basalt, how the solubility of carbon dioxide in the magma at 1150 degrees centigrade varies with pressure in megapascals. Figure 2 shows at 3 different pressures how the solubility of CO2 in rhyolite magma varies with temperature. And figure 3 shows at 3 different temperatures how the solubility in rhyolite magma at this temperature varies with the weight percentage of H2O in the magma. Okay. According to figure 2, at 300 megapascals, the solubility of CO2 in rhyolite magma is closest to 2000 ppmvu at which of the following? Okay. So it is closest to 300, right? So 2000 is closest to 800. Based on figure 3, at 750 degrees centigrade and 350 MPa, which one? 350 MPa. Okay. 750. Rhyolite magma having a solubility of equal to 1250 would most likely have a weight percentage of H2O. Okay, so 350 would be somewhere here, right? Like somewhere, something like this. 350 megapascals. Okay, so we are saying 1250. 1250 would be here somewhere. 5, right? Weight percentage of 5, between 4 and 6. According to figure 1, at 1150, the solubility of CO2 in basinite magma and in theolitic basalt is closest in value to which of the following? Basinite and theolitic. Basinite, yeah, at 50, wait, oh, they're closest in value. Okay, so basinite and Isn't that the closest basinite, the solubility and this basinite and okay. So it would be their closest in value. So it is the lower, right? 50 MPa and 200 MPa. 50 MPa and oh, okay, 1 second. Theolytic is like that. Yeah. Okay. So basinite, okay. Basinite at 50 and 125. 125 basinite is here, and theolytic at 250 is here, right? So 125 for basinite and 250 for theolytic. 125 and 250 for theolytic. Yeah, okay. Based on figure 1, at 1150 degrees centigrade and 150 this, solubility of CO2 is approximately how much greater? Okay, 150 MPa, right? 150 is this. So this and rhyolite, right? Leucetite and rhyolite. Yeah, so what is the difference? It is 3000 and rhyolite is about 700. So 2300 approximately, yeah. How much greater? It is 2300 greater for leucetite. According to figure 2, increasing the temperature from 650 to 1150 has the lesser effect on the solubility of CO2 in rhyolite magma at which pressure, 100 or 300? Okay, 650 to 1150. Solubility. Okay, we are going from 650 to 1150 temperature, at which it has the lesser effect at 100 or 300. Lesser effect on 100 because it doesn't change all that much. 100 because it decreases by how much? It decreases by, about 400. Yeah. So the lesser effect is here. Consider the solubility of CO2 in rhyolite magma at 750 and 200 MPa shown in figure 2. Okay, rhyolite's 200 MPa and 750. Okay, so we're looking at this graph. No, wait, figure 2. 1 second. 750 and 200. Yeah, so we are looking at this point, 1500. According to figure 3, this rhyolite magma has a weight percentage closest to which? 1500 is the solubility of CO2. Solubility of CO2 is 1500. So that's almost 0, right? It has a weight percentage of 0. Yeah. Okay. Passage 6. When viewed from Earth, the other planets in the solar system usually appear to have prograde eastward relative to the stars. Occasionally, however, each planet appears to briefly move retrograde westward relative to the stars. For example, figure 1 shows Mars's position relative to the stars on 9 dates between July 24 and February 26. Okay. 2 hypotheses were proposed to explain why the planets occasionally appear to move retrograde. Okay, so retrograde is westward movement and prograde is eastward movement. So why do they sometimes appear to move? 2005. Okay. So this part is the westward movement. This was the retrograde movement, right? Yeah. Earth is the solar system's central body. Okay, that's just the first line itself is so wrong. Earth is the solar system's central body and the other bodies move around Earth in looped orbits. Each body has 2 circles associated with it, a deferent and an epicycle. Both circles rotate counterclockwise and their combined motions result in a body following a looped orbit. In figure 2, the left panel shows Mars's deferent in epicycle and the right panel shows Mars's orbit. Okay. As a body passes through a loop, the body's motion changes from prograde to retrograde and back. The larger a body is deferent, the more loops in the body's orbit and the more often the body passes through a loop. Okay, all right. Hypothesis 2, the sun is the solar system's central body and the planets move counterclockwise around the sun in elliptical orbits. The larger a planet's orbit, the more time the planet takes to complete a revolution around the sun. As a result, the line of sight from Earth to a given planet drifts over time. Figure 3 shows the orbits of Earth and Mars and the positions of Earth and Mars on each of the 4 dates labeled in the figure. For each date, the line of sight from Earth to Mars is projected onto a view of the sky. There are 2 rules for apparent retrograde motion. A planet with an orbit larger than Earth appears to move retrograde whenever Earth passes between the Sun and that planet. The larger that orbit, the more often a pass occurs. A planet with an orbit smaller than the Earth appears to move retrograde whenever that planet passes between the Sun and Earth. The smaller that planet orbit, the more often this pass occurs. Okay. Right. So that's what we have here. Which of the following statements best describes the primary difference between the 2 hypotheses? Hypothesis 1 claims that all planets follow looped orbits around Earth, whereas that all planets follow elliptical orbits around the sun, right? So it's obviously F. Assume that figures 2 and 3 are drawn to scale. Which of the figures, if either, implies that the distance between Earth and Mars varies with time? Yeah, that 3 definitely applies that. The difference between, yeah, even 2 applies that. Both these figures imply that the distance changes with time. Consider both the interval of time represented in figures 1 and 3 and the reason that, according to hypothesis 2, the line of sight from Earth to Mars drifts if the top position of figure 3 consistent with that reason. It seems to be consistent, right? Let's look. Earth is shown as having the smaller orbit and as having completed a greater percentage of its revolution around the sun than is Mars. Yeah, Earth is shown to be a smaller orbit. Yeah, that is correct. And so it is, yeah, so it's correct. F is correct. Based on figure 1, as viewed from Earth, for approximately how many days between this and this did Mars move retrograde? Okay, as viewed from Earth, right? So it would be from 10-1 to 12-10. So that's for how many days? We are looking at July 24, right? So this is October 1 and this is December 10. So that's 31, 61, 70 days, about 70. Yeah. A supporter of hypothesis 1 and supporter hypothesis would both be likely to agree with which of the following statements? When viewed from Earth, if a planet appears to be moving prograde, that planet is actually moving if it is moving prograde, both circles rotate counterclockwise. Yeah, so it is rotating counterclockwise around the central body. They just differ on what the central body is. Based on figures 1 and 3, if hypothesis 2 is correct, which of the following figures would most likely show the position of Earth and Mars on November 7, 2005? Okay. November 7 is retrograde, right? So a planet with an orbit larger than Earth appears to move retrograde whenever the Earth passes between the sun and that planet. So, wait, where is the Earth? Yeah, the Earth passes between, yeah, the Earth passes between the sun and the planet. So it would be B. Yeah. That is when it moves retrograde. Okay. Can hypothesis to explain why Venus occasionally appears to move retrograde? Yes. Hypothesis to accounts for the motion of planets. Smaller than the Earth and larger. Yeah, so it accounts for both, right? It does account for the motion of planets that are closer. Okay, wait. Mercury, Venus, Earth, Mars. So it does account. So it accounts for the motion of planets that are closer to the sun. Okay, let's grade this. So we have from question 1 here. Okay. Just 1 second. Answer key for science. Yeah. AJDGD, AJDGD, 6GBGAH, GBGAH, 11, DHBGB, DHBGB, 16, HAFCF, HAFCF, okay, 21, CFDHB, CFDHB, 26, JBHCJ, JBHCJ, 31, BFAFC, BFAFC, 36, FBJBF, FBJBF. Okay, great. So we got all correct. So with this, we complete the science, math, and the English sections of the July 2020 ACT. Now we are only left with the reading solutions, which I'll try and upload soon. Do subscribe so that you get notifications when those solutions are uploaded. And let me know in the comment section what other videos you'd like me to upload. I'll see you guys in a new video soon. Take care. Bye.